Example 1.9. On R, let B be the collection of intervals from A to B, which contain the left endpoint but not the right. This collection B is a basis for a topology on R, as we've seen. We call the topology generated by this basis the lower limit topology, since each basis element contains this lower limit, A. And we denote the real numbers with this topology by R sub L. Problem 1.12. Determine which of the following are open sets in R sub L. In each case, prove your assertion. So remember, the question we're asking is, can we write each of these sets as a union of basis elements? Okay, that's what makes it open in the topology generated by the basis. Well, let's begin with A, the interval from 4 to 5, including 4. Well, this we see right away is open because it is an element of the basis. Right? If it's an element of the basis, then it's certainly a union of basis elements, just the union of a single basis element. So 1 down, 3 to go. Next we'll look at B, which is just a single number. And well, one way to see that this is not open is to notice that every basis element is an infinite set, meaning it has an infinite number of elements in it. So a union of basis elements must also be infinite, right? But this set B only contains one element. It's certainly not infinite. So it can't be a union of basis elements, and therefore it cannot be open in this topology R sub L. Okay. Now let's look at C, the interval from 1 to 2, which includes both 1 and 2. Now this is also not open, but we can't use the same argument as we did for B, because this is an infinite set. It has an infinite number of elements in it. What we can say instead is that it's not open because, well, if the element 2 of this interval were contained in some basis element, well, that would mean that 2 is strictly less than B. And so this basis element from A to B must also contain numbers greater than 2, right? For example, the average of 2 and B, right? Okay, well, if this set were open, it would be the union of basis elements. And so in particular, 2 would be contained in one of these basis elements. But then we've just proven that there would have to be numbers greater than 2 in that same basis element. And therefore the union of these basis elements would contain numbers greater than 2, and it could not equal C. Okay. So C is not open. D is going to turn out to be open because I can write it as a union of basis elements. Okay, well, what's the union look like? It's going to be the union from 2 up to infinity of the base element, which is the interval from 7 plus 1 over n up to 8. Okay. And that shows it's open because it's a union of basis elements. Okay. Now, the idea of what I've done here is, you notice I'm keeping the right endpoint fixed at 8. The left endpoint, when I is 2, is going to be 7 plus a half. And then when I is 3, well, that's not supposed to be an n. I got to make those agree, pardon me. When I is 3, it's 7 plus a third, and then 7 plus a fourth, and so on. And that left endpoint is just marching slowly towards the left, approaching the limit of 7. Right? But it never actually gets to 7, and so the union doesn't contain 7 itself, but it does contain everything between 7 and 8. Okay, so it contains exactly the elements of the set D. That does it.